Hello, today we're going to look at some examples of trigonometric functions of an acute angle. All right, and so the reason why they're called trigonometric functions of acute angles is because this applies to right triangles. And so if it's a right triangle, the other two angles have to be acute because the sum of interior angles of a right triangle any triangle is 180 degrees, and if 90 of them are already taken up, that leaves only 90 for the two others to split. Therefore, neither one of them can be obtuse, so they both have to be acute. All right, so here are the definitions. We have sine of A, and this is the abbreviation for sine, and sine is the opposite over the hypotenuse. Cosine, here's the abbreviation for cosine, is the adjacent over the hypotenuse. Tangent, the abbreviation for tangent is tan, and it is the opposite over adjacent. Cosecant is just the inverse of sine, and so as you can see, it is the inverse, so it is hypotenuse over opposite. Secant is the inverse of cosine, so it's hypotenuse over adjacent. And cotangent is the inverse of tangent, so it's adjacent over opposite. All right, so let's do an example. It says find the values of all 6 trigonometric functions for 45. Okay, so here is my angle 45, and as you can see, if I have an angle 45, the sides have been given to me. So everything I'm going to ask myself is in reference to this angle. So first we have sine, and I'm going to just say A, okay? I'm not going to say 45. I'm going to say sine of A. And if you remember, I'll write up here. Sine is the opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now this is a little acronym that people use to help them remember the trigonometric functions, and a lot of people call it SOHCAHTOA. So they make up this funny little story about an Indian girl or Indian boy who was named SOHCAHTOA because they had to soak their toe in a creek or river. There's many stories that have been made up. But anyway, this is how you remember it. This is the little acronym, SOHCAHTOA. So is opposite over hypotenuse. So my opposite is right here at 1. Hypotenuse is always directly across from the right angle, square root of 2. I'm going to leave it like this. We know that in algebra, we do not leave the radical in the denominator though, right? That's something that we already know. But I'm not going to take the time to do that, right? To evaluate that correctly. But I'm sure you already, this is starting to look familiar to you. Next we have cosine of A. And cosine of A is the adjacent to the hypotenuse. So the adjacent is this one right here. So that's 1. The hypotenuse again, it's going to stay the same as root 2. Tangent of A is opposite over adjacent. So the opposite is 1 and the adjacent is 1. So it's just plain old 1. All right. The next ones are very easy to find. So cosecant, all I have to do is flip it over, right? Because they're the inverse of each other. So I don't even have to use my triangle anymore. So that's root 2 over 1, which is just root 2. Secant, again, I'm just flipping this as the inverse or the reciprocal. So that's going to be root 2 again. And cotangent is the reciprocal of 1 is just 1. All right, let's do another one. Here we have a 30, 60, 90 triangle, and this time we're going to do it in reference to our angle 60. Oops, I started with cosine. I need to start with sine. So sine of A. Sine is SO, S-O, opposite over hypotenuse. So the opposite side is root 3, and the hypotenuse is 2. This is too close. I'm going to have to come down here. Forgive me. Cosine A is ca, so that's adjacent over hypotenuse. So the adjacent value here is 1. And the hypotenuse again is 2. Tangent is TOA, which is opposite over adjacent. So the opposite value is root 3. And the adjacent value is 1. Or just plain old root 3. Again, all I'm going to do is find the reciprocal, so I'm just flipping it. So that's going to be 2 over root 3. Again, we know we can't leave it like this, okay? Please know you cannot leave that radical down there. Secant is just 2 over 1, which is 2. And cotangent is just going to be 1 over root 3. But again, I cannot leave that root 3 there. So I hope these values are starting to look a little familiar to you, something that you've seen before. They're from the unit circle, right? They're all from the unit circle. So these are some of the values that we have on our unit circle. As you can see here for my triangle, this one I didn't do 30 degrees, but we know that our cosine is root 3 over 2 and our sine is 1/2. And then I have 45. This is our 45 degree here. So if I drew my triangle from here to here and came down, it would be, the cosine would be root 2 over 2. And we can go back to that. So we have 1 over root 2. Well, we know that, like I said, we cannot leave that root at the bottom. So I'm going to multiply top and bottom by root 2. And I'm going to come up here and write it. It's going to give me root 2 over 2. And so that's what I would get here. So we would get the cosine is root 2 over 2 and the sine is root 2 over 2. So these are the exact same values from our unit circle. All right, so let's put this into action with another triangle. First of all, this is a right triangle. It has to be a right triangle. And let's find sine, cosine, and tangent. Okay. So sine, they want us to do with A and B. So first we'll look at A. Everything in reference to A. Sine of A, sine is opposite. So opposite is 7 over hypotenuse. Hypotenuse is 25. Cosine of A, sorry I had notes, but I can't find them, so hopefully I remember to say everything. Cosine of A is going to be so cosine is adjacent over hypotenuse. So the adjacent is this one right beside it, which is 24, over the hypotenuse, which is 25. I'm going to come here and write tangent of A. And tangent is opposite over adjacent. So my opposite again is 7. And my adjacent is 24. So now let's do it in reference to B. Let's change the color so we don't confuse ourselves. So here's B. So sine of B, again, is opposite over the, I've lost my train of thought. It's opposite over hypotenuse. So my opposite side or my opposite, yes, my opposite side is going to be 24, and here's my hypotenuse, 25. So that's going to give me 24 over 25. Cosine is going to be adjacent over hypotenuse. So the adjacent is 7, and the hypotenuse is 25. And then tangent is adjacent over, opposite over adjacent. So the opposite side again is 24, and adjacent side is 7. Okay, so let's think about this for a second. I hope that you see some kind of similarities here. For example, notice these values are the exact same, and these two values are the exact same, and these two values are the exact inverses of each other, are the reciprocal of each other. So let's look at it a little further. So these are called cofunction identities, and this is just kind of like what we showed on the previous slide. And it says for any acute angle in standard position, it doesn't say this, but the complement, and that's what that 90 represents, the complement, that means the two angles add up to 90 of each other, are equal to each other. So going back, these two angles have to be complements, because if this angle is equal to 90, that means there's only 90 degrees left in my triangle total. So B plus A has to be equal to 90. So they're the complements of each other. So the complements, sine and cosine of each other, are equal. Sine and cosine are equal. And as you can see here, sine and cosine are equal. Tangent and cotangent are equal. And then, of course, the reciprocals are equal to each other. So if sine and cosine are equal, then cosecant and secant are equal. Okay? Here's another way of looking at it in case that way was a little confusing. So again, sine and cosine are equal. Secant and cosecant are equal. And these are the A and B represent the complements of each other. So instead of that, minus 90. And tangent and cotangent are equal. Remember, cotangent are reciprocals of each other, and that's what we show in the other example. So let's do a few examples. So if we have cosine, we know that sine is the cofunction for it. So that's going to be sine of 90 minus 52. And so that's going to be sine of 38. The next one, tangent, oops, not tangent, cotangent. It's going to be 90 minus 71. And that's going to give me cotangent of 19. And then secant, remember, is cosecant. So it's 90 minus 24 is equal to cosecant of 66. And I hope that this helps.